Okay, so in this lecture, we're going to discuss the action potential. We're going to fill in the gaps of knowledge that we've already discussed for the neuromuscular junction. So we've already learned that here on this model, the action potential travels along here through the axon, and then once it gets to the axon terminal, there's a release of acetylcholine. Acetylcholine is a neurotransmitter. And so the neurotransmitter gets released here into this part, which is known as the motor end plate. And once acetylcholine binds to its receptor, we get the flux of ions. And so the flux of ions leads to the action potential that travels along the sarcolemma of the muscle fiber. And so when I say flux of ions, what I'm discussing is sodium and potassium. So let's get into what an action potential is. So what you're looking at, this is a graph that represents voltage. Okay, so think about this as current that's flowing. Okay, so the negative, so you have negative 70, negative 50, and then once you go above zero, obviously the number is getting more positive. And so during an action potential, the membrane potential, which is, so this is my phospholipid bilayer here. So we're measuring the difference in the concentration of sodium and potassium here along this membrane, okay? And so in order for an action potential to happen, it becomes more positive, right? But in order for the cell to become more positive, we need a positive thing, okay? And so that positive thing is sodium. And so what will happen is what negative 70 is representing, so this is the resting membrane potential, and then this is what we know as threshold, which is at negative 50. So once we reach threshold, which is at negative 50, then we get this spike here, and due to the sodium that's rushing in, okay? So the first event where sodium rushes in is known as depolarization. So you have depolarization whenever the membrane potential becomes more positive, so it's going up, 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 up. And then once we reach the peak, the sodium channel, so at the peak, the sodium channel is going to close. So when the sodium channel closes, the potassium channel will open. And so when the potassium channel opens, the positive thing, which is known as potassium, is leaving. So if a positive thing is leaving, what's going to happen to the membrane potential? Yeah, it's going to go down, right? It's going to become more negative again because the positive thing is leaving. And so at point 2, we know this as repolarization. So during depolarization, we'll write that the sodium channel opens, right, for this part to come, and then once it reaches the peak, so at the peak, the sodium channel will close, and then the potassium channel will open. So when the potassium channel opens, potassium leaves the cell, and then it becomes more negative once again. The event is known as repolarization. Once we go past this point here, where we go past what's known as the resting membrane potential, that's what we know as hyperpolarization. And so that's what this curve here is indicating, and then it'll go back to resting membrane potential. Okay, so revisiting from the very beginning, this is what's representing the axon terminal. Acetylcholine is here in the vesicle. Acetylcholine gets released due to calcium that flows in, so calcium will flow in. That's what causes the release of acetylcholine. It'll bind to its receptor. once acetylcholine binds to its receptor, we have the flux of our ions. So sodium goes in, potassium goes out, and this will continue to happen all along what part? The sarcolemma. So remember, it goes, the action potential will travel all along the sarcolemma before it reaches the T tubules, which are here. And then it continues that whole process that we've already discussed. Okay? All right, so that concludes the lecture on the action potential. Are there any questions?